SMB evasions, right? Server mesh block evasions. So transfer protocol used by Microsoft in standby implementation allows for remote file access, a lot of times through a share. We have the network authentication that kind of controls there too. So again, we kind of mentioned this whole thing about like your null sessions and such, right? That kind of comes into play there. Port 445, things like that, which is SMP over TCP/IP. And of course, your RPCs, your remote procedure calls, and system administration can also be done on the evasion side. Now, we also have vulnerabilities, which basically allows for malware propagation. It also, interestingly enough, goes into remote registry access as well, which is, again, kind of an interesting concept there. Now, authentication attacks, of course, could occur here, and we also have the DCE, right, RPC transport, which you can check out on your DCOM and some of your MS practice out there too. And we'll talk here in a moment about some more DCE, RPC stuff and so forth, right? Because it's all going to be part of that stuff. So what else we got? So how can an IDS control some of your SMB sessions that we got going on? Well, keep in mind, this is all mainly done through the use of a signature. So give your Johnny Hancock right there, please. And also it goes along with the state and signature of it all. And we also have the state, the content, context in this case, and a signature as well. So to get overall, we need to somehow get some complete protocol emulation going. We need to, of course, figure out what version, which version we're running, and which version of specific options that we have for that particular version that we figured out, and then also what vendor specific options that we may have available to help control overall SMB sessions going across our network, because we tend to have, for some reason, a Microsoft network out there that allows us, of course, to transfer files, have people access files on remote servers, and have all kinds of things going. And we love to share information as long as it's within the company, right? Now, we don't like sharing information online or making things accessible online for others to see, but we love to share it inside. And since most of corporate America out there seems to be using Microsoft-based systems, it should be pretty straightforward, right? SMB is definitely not going away. Anytime you're sharing anything, there it goes. We're using it. So we need to figure out all that fun stuff, right? And of course, with the IDSs, we put it all together. Put the vendor, put the version, and then see what all we can put it and mix it all up in a big nice pot, and then come up with a good solution. And obviously, there is thinking hopefully a little bit outside the box and coming up with something very nice for your specific scenario. That's again something that's just going to be around. And what do you know? That's where it goes. Okay, distributed computing environment, remote procedure call evasions. Now, to kind of get into DCE RPC, we need to kind of figure maybe a little bit about it. So I'm going to mention some things here that might be pertinent to know when it comes down to it. And obviously what it is, it's a facility for calling a procedure on a remote machine as if it were a local procedure call. Now, to the application programmer, a remote call looks almost like a local call. But there, of course, are going to be several RPC components that work together to implement this facility, including the interface definition language, also known as the IDL, and its compiler, the UUID, which is your Universal Unique Identifier Generator, and the RPC runtime, which supports two RPC protocol implementation. One RPC protocol operates over connection-oriented transports, such as the TCP/IP, and the other RPC protocol operates over connectionless transports, such as your UDP/IP, as in your user datagram internet protocol. Right? End user does not see the remote procedure call at all, and the minimum amount of administration involved in RPC can usually be handled by the server-side application code, such as advertising an application server in the DCE directory service. It is the application programmer who most comes into contact with the RPC component. And I believe we have some programmers in the mix this week. Since many of the DCE components are themselves client-server applications, they use RPC as their basis for distributing applications for distributed communications. The components that comprise the DCE RPC are follows, as we have what's called the IDL, as I mentioned already. It's the interface definition language and its compiler. An RPC interface is described in the DCE IDL. The IDL file is compiled into object code using the IDL compiler. The object code is in two main parts, one for the client side of application and, of course, one for the server side. We have the RPC runtime library. This library consists of a set of routines linked with both the client and the server sides on the application, which implement the communications between them. This involves the client finding the server in the distributed system, getting messages back and forth, also managing any state that exists between the requests, and then also processing any errors that may occur. We have the authenticated RPC, which here your DC